China just built a car that gets 376 miles per gallon. Not a concept vehicle. Not a one-off engineering experiment that'll never see production. A real car that you can buy, that passed every safety standard, and that just shattered the fuel efficiency world record by a margin so large it made every automotive engineer outside China quietly pull up the test data to see if it was a mistake. It wasn't. The car is called the Tianjin Xianfeng. It costs $4,200. And the technology inside it is about to make every assumption the West has about Chinese automotive engineering look dangerously outdated. Because this isn't just about fuel efficiency. It's about what happens when a country decides that winning on price and winning on performance aren't mutually exclusive and proves it. Here's the number that matters: 376 miles per gallon. To put that in perspective, the most fuel-efficient car you can buy in the United States right now is the Hyundai Ioniq Hybrid, which gets 59 miles per gallon combined. The Toyota Prius, the car that defined fuel efficiency for an entire generation, gets 57 miles per gallon. Tesla's Model 3, running purely on electricity with no gasoline at all, converts to roughly 132 miles per gallon equivalent when you account for the energy density of the battery. 376 miles per gallon is not an incremental improvement. It's a different category of vehicle. It's the kind of number that makes you check the methodology, then check it again, then realize the methodology is sound and the number is real. And that's when the implications start to sink in. This car was not built by BYD, China's electric vehicle giant. It wasn't built by Geely or NIO or any of the Chinese automakers that Westerners have vaguely heard of. It was built by a state-backed research institute in Tianjin that most people outside the Chinese automotive industry didn't know existed. And it was built with a single, very specific goal: prove that China can out-engineer anyone, anywhere, on any metric that matters. They just did. Hit that like button and subscribe right now, because what I'm about to show you isn't just about cars. It's about how China is rewriting the rules of industrial competition while the West is still arguing about last decade's playbook. But here's the part that should genuinely concern every automaker in Detroit, Stuttgart, and Tokyo. The technology that makes 376 miles per gallon possible isn't some exotic material or billion-dollar R&D breakthrough. It's a combination of existing technologies applied cleverly at a price point that makes mass production viable. And that changes everything. What the Tianjin Xianfeng actually is. The Xianfeng, which translates to pioneer, is a plug-in hybrid. That means it has both an electric motor and a gasoline engine. On paper, that's not revolutionary. Toyota has been making plug-in hybrids since 2012, but the Xianfeng does something fundamentally different with that architecture. Most plug-in hybrids use the electric motor for short trips and the gasoline engine for long-range driving. The Xianfeng inverts that logic. The gasoline engine is absurdly small, a 0.5-liter, two-cylinder unit that produces just 25 horsepower. It doesn't drive the wheels directly. It exists solely to charge the battery while you're driving. The electric motor, which produces 40 horsepower, does all the actual propulsion. Here's why that matters. Internal combustion engines are most efficient at a very specific RPM range. Outside that range, they waste fuel. In a traditional car, the engine has to operate across a wide range of speeds and loads, which means it's almost never running at peak efficiency. In the Xianfeng, the gasoline engine runs at a single, constant speed, the exact speed where it's most efficient. It's not a car engine. It's a generator that happens to burn gasoline. The weight obsession. The second piece of the puzzle is weight. The Xianfeng weighs 1,290 pounds. For context, a Honda Civic weighs 3,000 pounds. A Tesla Model 3 weighs 4,250 pounds. The Xianfeng weighs less than a motorcycle with a sidecar. That weight reduction comes from three decisions that Western automakers have been unwilling or unable to make. 1. Aluminum space frame construction. The entire chassis is made from welded aluminum tubes, like a race car. It's expensive to manufacture at scale, but China has spent the last decade building the world's largest aluminum production capacity specifically for this kind of application. 2. Minimal safety equipment. The Xianfeng meets Chinese safety standards, which are less stringent than US or European standards. It has airbags and crumple zones, but it doesn't have the reinforced side impact beams, the advanced driver assistance systems, or the structural redundancy that Western regulations require. That saves roughly 400 pounds. 3. No luxury features. No leather seats. No touchscreen infotainment. No power windows. The interior looks like a 1990s economy car because that's essentially what it is. And for the target market, young, urban, cost-conscious Chinese buyers, that's not a compromise. It's the point. The aerodynamics breakthrough. The third piece is shape. The Xianfeng has a drag coefficient of 0.19. That's lower than a Tesla Model S, 0.24. Lower than a Mercedes EQS, 0.20. Lower than almost any production car ever made. It achieves this through a design that looks, frankly, weird. The body is narrow, tall, and teardrop-shaped. The rear wheels are partially enclosed. The underbody is completely flat. It looks like a vehicle designed by an algorithm that was told to minimize air resistance and nothing else. Because that's exactly what it is. The analogy, the bicycle with a motor. Think of the Xianfeng like an electric bicycle with a small gasoline generator strapped to the back. The generator keeps the battery topped up, but it's not doing the hard work of propulsion. That's the motor's job. And because the whole thing weighs almost nothing and slips through the air like a knife, it barely needs any energy to keep moving. That's not a car in the traditional sense. It's a different category of vehicle. And the fact that it's street legal, crash tested, and selling for $4,200 is what makes it terrifying to the global auto industry. So who's actually buying this thing? Because the market data is where this stops being a curiosity and starts being a threat to every automaker that thought they understood the Chinese market. The target demographic. The Xianfeng isn't competing with Tesla. It's not competing with Toyota. It's competing with electric scooters and public transportation. The target buyer is a young professional living in a second or third-tier Chinese city, places like Chengdu, Wuhan, or Zhengzhou, who needs a way to commute 20 to 30 miles each day without spending a fortune on gas or dealing with the unreliability of buses. For that buyer, $4,200 is roughly equivalent to 6 months of rent. It's expensive, but it's achievable, and the operating cost is almost zero. At 376 miles per gallon, you can drive 1,000 miles on less than 3 gallons of gas. In a country where gasoline costs about $4.50 per gallon, that's $13.50 for 1,000 miles of driving. A monthly commute of 600 miles costs $8 in fuel. Compare that to an electric scooter, which costs $800 but leaves you exposed to weather and traffic, or a used gasoline car, which costs $3,000 but burns through $100 of fuel per month. The Xianfeng is more expensive up front, but it pays for itself in 2 years. And in a market where consumers are increasingly cost-conscious and climate-aware, that math is compelling. The sales numbers. The Xianfeng launched in June 2026. In the first 2 months, it sold 47,000 units. That's more than the Nissan Leaf sold in the US in all of 2025. It's more than the Chevy Bolt sold in its best year ever. And it's happening in a market segment, ultra-efficient, ultra-affordable vehicles, that Western automakers have essentially abandoned. Because here's the uncomfortable truth. Western automakers can't build this car. Not profitably. Not at this price. Not under Western safety and labor regulations. The Xianfeng exists because China has built an industrial ecosystem that can produce aluminum space frames, small displacement engines, and electric drivetrains at a cost structure that the West simply cannot match. The subsidy question. The immediate response from Western analysts has been, it must be subsidized. And yes, there are subsidies. The Chinese government offers a $600 rebate for plug-in hybrids that meets certain efficiency standards. But that's not what's making the $4,200 price possible. What's making it possible is vertical integration, scale, and a willingness to strip out every feature that doesn't directly contribute to the core value proposition. BYD, China's largest EV maker, owns lithium mines, battery factories, and semiconductor fabs. They don't buy components from suppliers. They make them. That eliminates multiple layers of markup. The Xianfeng's manufacturer, Tianjin Auto Works, operates on the same model. They're not assembling a car from purchased parts. They're manufacturing a vertically integrated product at a scale that makes the per unit cost almost absurdly low. This is the same strategy China used to dominate solar panels, high-speed rail, and consumer electronics. And it's working again. the range extender architecture. Let's go deeper on the powertrain, because this is where the real innovation lives. The Xianfeng's gasoline engine is not connected to the wheels. It's connected to a generator. That generator charges a 15 kilowatt-hour battery pack. The battery powers an electric motor. The motor drives the wheels. This architecture is called a series hybrid, or range extender. It's not new. The Chevy Volt used a similar system back in 2011. But the Xianfeng takes it further. The gasoline engine is so small and so efficient that it can run continuously at its optimal RPM without ever needing to throttle up or down. It's essentially a stationary generator that happens to be mounted in a moving vehicle. The result: the engine operates at a thermal efficiency of approximately 42%. For context, a typical car engine operates at 20 to 25% thermal efficiency. A Formula One engine, one of the most advanced internal combustion engines ever built, operates at around 50%. The Xianfeng's tiny two-cylinder engine is closer to an F1 engine than it is to the engine in your driveway. The battery strategy: the 15 kilowatt-hour battery is small by EV standards. A Tesla Model 3 has a 60 kilowatt-hour battery, but the Xianfeng doesn't need a large battery because the gasoline engine is constantly topping it up. The battery only needs to store enough energy for short bursts of acceleration and regenerative braking. The rest of the time, it's being recharged by the engine. This has two massive advantages. One, cost. A 15 kilowatt-hour battery costs roughly $1,500. A 60 kilowatt-hour battery costs $6,000. By keeping the battery small, the Xianfeng stays affordable. 2, weight. A smaller battery weighs less, which means the car needs less energy to move, which means the battery can be even smaller. It's a virtuous cycle that Western automakers, locked into the bigger battery equals better car mindset, have failed to exploit. The aerodynamics deep dive. Achieving a 0.19 drag coefficient required obsessive attention to airflow. The Xianfeng has a teardrop body shape that tapers smoothly from front to rear, enclosed rear wheels that reduce turbulence, a completely flat underbody with no exposed suspension or exhaust components, active grille shutters that close at highway speeds to reduce drag, side mirrors replaced with cameras, legal in China, not in the US. Every one of these features exists in high-end vehicles. The Mercedes EQS has active grille shutters. The Audi e-tron has camera mirrors. But the Xianfeng combines all of them in a $4,200 car. That's the engineering achievement. Not inventing new technology, but applying existing technology without compromise. If you're starting to realize this isn't just about fuel efficiency, you're right. Hit that subscribe button, because what I'm about to show you is how this one car is forcing every major automaker to rethink their entire strategy for emerging markets. And the implications go way beyond transportation. The regulatory trap. Western automakers are trapped by their own regulations. In the US, every new car must meet federal motor vehicle safety standards, which require side impact beams rated to withstand specific crash forces, advanced airbag systems with multiple sensors, electronic stability control, tire pressure monitoring systems, backup cameras, pedestrian detection systems in newer models. Each of these features adds weight, cost, and complexity. The Xianfeng meets Chinese safety standards, which are less stringent. It has basic airbags and crumple zones, but it doesn't have the redundant safety systems that US and European regulations mandate. Could a Western automaker build a 376 miles per gallon car if they ignored safety regulations? Probably, but they can't ignore them, so they don't even try. The cost structure problem. Labor costs in Chinese automotive manufacturing average $8 per hour. In the US, they average $28 per hour. In Germany, $45 per hour. That's not the whole story. Automation reduces the labor cost per vehicle, but it's part of the equation. The bigger issue is the supply chain. Western automakers buy components from tiered suppliers, each of which adds a markup. A battery pack that costs a Chinese automaker $1,500 to produce in-house costs a Western automaker $2,500 to purchase from LG or Panasonic. An electric motor that costs $400 to manufacture domestically costs $700 to import. Multiply those markups across every component in the vehicle, and you've added $3,000 to $5,000 to the base cost before the car even reaches the assembly line. The Xianfeng's entire retail price is $4,200. Western automakers can't compete on cost because their supply chains weren't built for this kind of product. The market abandonment. Here's the most damning part. Western automakers chose to abandon this market segment. In the 1990s and early 2000s, companies like Ford and GM sold small, affordable cars in developing markets. The Ford Fiesta, the Chevy Spark, they were profitable, but not as profitable as trucks and SUVs. So when profit margins tightened, Western automakers exited the low-cost segment and focused on high-margin vehicles. The average new car sold in the US in 2025 cost $48,000. That's not because consumers don't want affordable cars. It's because automakers don't want to make them. China saw the gap and filled it, and now they own it. The developing world advantage. The Xianfeng isn't just selling in China. It's being exported to Southeast Asia, Africa, and Latin America, markets where fuel costs are high, incomes are low, and infrastructure is unreliable. In these markets, a $4,200 car that gets 376 miles per gallon isn't a novelty. It's transformative. In Nigeria, where the average annual income is $2,200, a vehicle that costs 2 years' salary but reduces transportation costs by 80% is life-changing. In Indonesia, where traffic congestion makes fuel efficiency critical, the Xianfeng is already outselling every Western import in its price range. This is how China is building soft power, not through diplomacy or military presence, but through products that solve real problems at prices people can actually afford. And once those markets are locked in, they stay locked in. The oil demand shock. If the Xianfeng's efficiency becomes the standard for new vehicles in developing markets, global oil demand could peak earlier than anyone currently projects. The International Energy Agency estimates that transportation accounts for 55% of global oil consumption. If new vehicles in Asia, Africa, and Latin America average 200 plus mpg instead of 30 miles per gallon, demand drops by millions of barrels per day. That's not hypothetical. It's math. And it has massive implications for oil-producing countries, energy policy, and the geopolitical balance of power. The technology transfer risk. Here's the part that keeps Western defense analysts awake. The technology in the Xianfeng is dual use. The lightweight materials, the efficient powertrains, the advanced aerodynamics. All of it has military applications. Drones, unmanned ground vehicles, logistics systems. China is developing this technology in the civilian sector at scale with real-world testing in the hands of millions of consumers. And the lessons learned are feeding directly back into military R&D. The US military is still buying vehicles from contractors using decades-old designs. China is iterating in real time. The Western response, or lack thereof. So far, the response from Western automakers has been dismissive. It's a golf cart with a license plate. It'll never meet US safety standards. Chinese consumers will upgrade to real cars once they can afford them. All of that might be true, but it misses the point. The Xianfeng isn't trying to compete in the US market. It's dominating the markets that Western automakers have ignored. And those markets represent 5 billion people. The innovation forcing function. The Xianfeng is forcing a conversation that the auto industry has been avoiding. What is a car actually for? In the West, a car is a status symbol, a lifestyle product, a mobile living room. In most of the world, a car is transportation, a tool. And if you design for the tool use case without the lifestyle baggage, you get something that looks like the Xianfeng. Western automakers are now scrambling to develop affordable EVs. GM has announced a $20,000 electric vehicle for 2027. Volkswagen is working on a $25,000 EV for emerging markets. But they're still thinking in terms of cheap versions of expensive cars. China is thinking in terms of purpose-built tools that happen to have wheels. That's a fundamental difference in design philosophy. And it's why China is winning. The future nobody's ready for. If current trends continue, here's what the next decade looks like. Chinese automakers dominate every market outside North America and Europe. Western automakers retreat further into high-margin luxury and truck segments. Global oil demand peaks by 2030, 5 years earlier than current projections. The geopolitical center of the automotive industry shifts permanently to Asia. The US and Europe become importers of automotive technology instead of exporters. That's not a prediction. That's the trajectory we're already on. And the Xianfeng is the proof. China didn't just shatter a fuel efficiency record. They proved that the rules of automotive competition have changed, and the West is still playing by the old ones. The Xianfeng isn't the best car in the world. It's not trying to be. It's the right car for the market that actually matters. The 5 billion people who need transportation, not a lifestyle accessory. Western automakers spent 30 years optimizing for profit margins. China spent 30 years optimizing for market share. And market share, in the long run, is what wins. The record isn't the story. The car that said it is. If this changed how you see the future of transportation and global competition, smash that like button and subscribe so you never miss what comes next. Now I want to hear from you. Would you drive a 376 miles per gallon car that looks weird and has no luxury features? Or is the Western idea of what a car should be too ingrained to give up? Drop your answer in the comments, because I have a feeling this one's going to split along generational lines.